Namaskar, hello and a very warm welcome to ET and ICT's special live phone-in interactive program. My name is Tanvi Khurana and here we are with a series on ET and ICT tools. Today we are going to discuss exploring Tinkercad for teaching learning. Well, what exactly is Tinkercad? And as you all know that ICT tools, they are not just optional anymore. Every teacher likes to use ICT tools and teaching them, it becomes really easy for them to teach the students using the ICT tools, and they are extremely necessary for the entire classroom. So this is not an option. Tinkercad, how is this particular tool important? Well, you will get to know all the answers in this particular session. If you have any questions and you want to reach us, give us a call on our number, which is 8800 and you're watching us on eVidya channel number 6 to channel number 12. So one more option we have through which you can connect with us, and that is our email ID, which is training.helpdesk@ciet.nic.in. You're also watching us on our YouTube channel at this moment, which is NCERT Official. In the live chat box, you can write down your questions, your queries, and share them with us. We have an expert in our studio and she's going to be here till 5 o'clock. So we have a lot of time to take up your queries. Let me please introduce to you our today's guest. She is Miss Anshul Nagpal. A very warm welcome to you, ma'am.
Thank you.
Ma'am is an academic consultant from Central Institute of Educational Technology, which is CIET and CRT. And I have a lot of questions to ask her. So without wasting any more time, let's begin this conversation. And the basic question I would like to ask you would be, ma'am, what exactly is Tinkercad? How is it useful for our viewers, especially the teachers who are going to use this ICT tool? And would you also like to demonstrate it and show each and every button, each and every tool, how they can actually use it?
Sure. So Tinkercad, it's basically an online platform for teachers, students, and they can learn 3D designing, electronics, and integrate other subjects as well into their teaching learning.
Okay, so shall we begin?
Yes.
Okay, so this is going to be a very interesting conversation, and because she'll be demonstrating Tinkercad to all of us, I think we will understand each and every minute detail about Tinkercad and what are its usages and how is it going to be useful for the teachers who are aiming for any specific subject. So that is also going to be one of my questions. So let's go to ma'am once again and let's try and understand what she has for all of us. Ma'am.
So, as you know, National Education Policy, it talks a lot about ICT tools and integrating them into teaching learning.
Yes.
And the importance of optimizing and expanding the existing digital platform that has become the need of an hour. Now, what are we going to explore in this session? As you said, we'll be learning about Tinkercad and specifically focusing on what is it, why do we use it, and how do we use it, and where teachers can use Tinkercad. So answering to your first question, what is Tinkercad? Tinkercad, it's an online software. Basically, primarily it is used for 3D designing, circuits and coding. And it's an effective tool to integrate STEAM in education.
Okay. STEAM, it's written in bold and in caps. Is it an abbreviation of something?
Yes. So STEAM is what we are going to explore. What is STEAM? And as we mentioned, primarily it is 3D designing, circuits and code blocks. However, how can we integrate other subjects into this? That we are going to explore on the interface.
Sure.
Coming to STEAM, it's an abbreviation for Science, Technology, Engineering, Arts and Mathematics. So as you know, we are talking so much about art integrated learning.
Yeah.
And at the same time, interdisciplinary approach, multidisciplinary approach. So this software is a way to integrate all of them into the teaching learning process.
Okay.
Now, who can use Tinkercad? So this software is basically for students, teacher educators, teachers, and anyone who is passionate who is a hobbyist, who is passionate for 3D designing, learning new things. Anyone can explore the software. Let us discuss about some of the features of Tinkercad. So that you will be seeing while I'll take you through the interface. It has got a learning center. Then we have some sample projects. Then there is a gallery, lesson plans and help center. So that student, teachers and teacher educators, all of them can explore the interface and learn new things.
Okay.
Let us move to some of the advantages of Tinkercad. First is it provides hands-on experience in the virtual world. So if I take you back to 2020 COVID time, when all of a sudden schools got shut, and almost it was like a situation where an education system was about to come to a complete halt. At that time, this softwares like these, ICT played a very important role. And such softwares helped in providing hands-on experience even in the virtual world.
Okay.
Then we have student-centered personalized learning. It's a self-paced software wherein students can explore and learn at their own pace. It provides personalized learning because more the students are taking part, the more they are exploring on their own. They are taking the ownership of their learning, and eventually it's like learning is happening in its most effective manner. Then it helps in designing prototypes for projects. So also you'll see a lot of ideation and design thinking is going on in schools. A lot of schools have innovative labs set up. Then there are students who are working on design thinking, who are coming up with new ideas. So it's a great software for them to put their ideas into action and design certain prototypes. And of course, it cultivates skills of 21st century. And again, I would like to highlight the fact that all these things are in demand for the education sector. They are need of the hour, and they have been extensively discussed in our National Education Policy 2020. Now, when I say cultivating skills of 21st century, so this is a software that allows a child not only to explore the learning, whatever concepts a teacher has to take up in class, but at the same time, it also promotes qualities like decision making, then communication skills, design thinking. It promotes interactive learning. Okay, moving ahead. Trends in education. So art integrated education, as I mentioned, it is very much in demand. Right, and we are trying to integrate different subjects. Then toy-based pedagogy, design thinking and game-based learning. All these things are promoted by Tinkercad. Now, how? So we have been talking a lot of at the theoretical front, but how? What are we doing? So what do you need? First of all, it's a desktop based application. So you require a desktop or a laptop. Then internet connectivity, as it is an online tool, and you need to have a Gmail account, a Google account, so that you can take up the login process. How? So we need to log into www.tinkercad.com, wherein you will sign up with your Google account, explore and learn the interface, and then create your own designs. As I said, we'll be logging on to www.tinkercad.com. So you can see this Autodesk Tinkercad screen,
Right.
wherein all these features are mentioned. Like we have Tinker, 3D design, circuits, code blocks. Now I'll be going into detail of each one of them to provide better clarity. But before that, I would like the viewers to focus on signing up if they have not signed up, and it's a one-time process. So once you need to sign up so that next time you can log in.
So is sign up mandatory?
Yes, sign up is mandatory to learn more about Tinkercad. Otherwise, basically when you are working on designing your own designs, at that time you have to sign up.
Okay.
Sign in, you have to log in, and sign up is a one-time process that has to be done. So once you get yourself registered, you have to log in every time. It is just a kind of registration process. Now, the moment I clicked on sign up, I got these options: start tinkering, how will you use Tinkercad, then if teachers want to create a community of students, if they want it to be at the school level, they can register as a school. So educators start here and they'll get a code. This code they can give to their students, wherein the students can join a class. However, if the students are exploring or any individual is exploring the interface, they can create a personal account. The moment you click on create a personal account, you can sign in with your Google account. You also have sign in with Apple or more sign in options. And once you have done this one-time registration process, you can simply sign in next time to join Tinkercad. Okay. So since I had already signed in using my account, I would just like to demonstrate it to you. I am signing in using my Gmail account. The moment you enter your password, there is a two-step verification. So you will get a code on your registered number.
Okay.
You can see it's a two-step verification. I am not signing into my Gmail account. I am signing into Tinkercad.
Okay.
So now why I'm mentioning this is because we do teach, going into these ICT tools. But the very primarily basic steps, if these are ignored, obviously children won't choose to sign in.
Right.
And especially logging in is the most, it is very important that you start it in the right manner.
Okay. And this two-step verification, if I'm not wrong, it is for the safety and security
Right.
reasons, right?
So
Okay.
that is for the safety reasons.
Okay, so I hope our children, our viewers, they have signed it along with us, and you're also doing the two-step verification at this moment. And very quickly, when ma'am will be logging in, and then we can see that how exactly Tinkercad works, and how for using different type of subjects, for the explanations, for the science experiments, maybe how we can use Tinkercad for the benefit of the children. So there's a lot to understand here, and if you would like to ask us any questions, please raise it, and NCERT Official, that is our YouTube channel, in the live chat box, write down your questions and share them with us. So I think ma'am has logged in right now, so
Yes.
let's have a look at the web page right now.
Okay, so this is the Autodesk Tinkercad. Now, one thing to see is that this is my login. So now I have signed into it, and earlier the screen that you were seeing, the login was not there. So similar tabs were there wherein you can just simply explore what is it about. However, since I have logged in, we'll be creating one exciting circuit as well. So let us first just explore the interface. Now, because I logged in with this mail ID and name, so here you can see my name, and also it is important to see tutorials are mentioned here. As I said, it is a self-paced learning software. Children can explore, teachers can explore it using tutorials. Moving to the first subhead, that is Tinker. So 3D designing circuits and code blocks. You can design your own 3D model in just minutes, and circuits, you can create any circuit, and code blocks is for coding. Then here we have gallery. So within gallery you have designs for all the 3 subheads. These are the collection of various designs that have been created on Tinkercad. Then we have projects. These are all sample projects. So if I'm clicking on all, I have all the sample projects displayed here. Then we have 3D design, wherein all the projects are related only to the 3D designing part. We have circuits, so projects based on circuits, and code blocks. Now, one thing I would like the viewers to pay attention to is grades. So this should not be a misconception that such a software is for one particular project, one particular grade or subject. We can see it offers projects for all grades. Also, a lot of schools, a lot of teachers are working towards project-based learning. So this software can help them to look for an appropriate project based on the need for their classroom. So you can see it has all the grades right from kindergarten to 2. Then it is subdivided. Grade kindergarten to 2, then grade 3 to 5, then 6 to 8, 9 to 12, and university level. Then considering the subjects, we have a long list of subjects. So as I was telling you, it's a STEAM-based, it promotes STEAM-based learning as well. We can see it's not only about maths and science, we have projects on arts, music, 3D designing, 3D printing, etc. And this is how you wish to see the project. So do you wish to see only the recent ones or mostly viewed ones? Then we have classrooms. So here, if I take back to the login part, wherein I was sharing that you can create your own classroom, educators can register here and invite their students through a code. So this can be done. This is the classroom. Now resources. So it has a block, Tinkercad block, then some tricks on how to use the software. Then we have a learning center, which has got tutorials for everything. Like if you want to learn 3D designing, how to assemble circuits, coding. So it has got easy tutorials, irrespective of the background that you have, whatever educational background you're coming from, you can learn these softwares, this through tutorials. Then we have lesson plans. So in the life of a teacher, lesson plans play a very crucial role. And here you can see there are all sample lesson plans. So the grade is mentioned, subjects is mentioned, and they can be customized as per the need of your class. Then we have designing an inclusive play space. All these lesson plans can be explored and based on the subjects as well. All right. Now, proceeding to the workspace. And exploring the separate workspace that I've been talking about. So we'll discuss some circuits. I come back to Tinker and I click on circuits. So this is basically the workspace that we'll be working on. Start tinkering. Now whatever designs that you are working on, whatever you are creating, they will be auto-saved, they'll be saved in the software itself, and so that next time you log in, you have your own collection. Now since I said we'll be working on circuits, I click on circuit and I move to new. So here when I click on new, it will be asking me whether I want to design a 3D prototype, or I want to work on circuits, or I want to work on code blocks. So I click on circuit. All right. So this was a design that was already made. Yes. And this is my workspace. Now let us explore the workspace. Okay.
So generally, ma'am, how much time do you take to make one design?
So basically it depends on the design as well.
Okay.
And how much efficient you are with the tool. So as and how you explore it, you learn new things, you'll realize that you're gaining perfection over it, and then it will take less time. Initially, you might take more time, not because you are a slow learner, but because you're exploring as well. So a lot of tools you will realize while making them, you'll see that you are able to make once you explore them clearly. Like, for example, in class 6 only, we have basic electronics, right? But children have an exposure of laboratory in grade 9. So this is something wherein each and every child can make use of electronic components. They can try. From safety point of view also, we would not suggest just giving simply electronic instruments in the hands of children. This is one thing wherein they are learning circuits and they are exploring it at the same time. They can make combinations, and if it doesn't work, then also because it is an ICT tool, they are seeing what is working for them. However, it is not harming them, it's not impacting them. So their safety is also considered. Now here we have basic components. So it is focusing on all the basic electronic components. You can also move to complex component. It has got Arduino, microbit, circuit assemblies based on the need. So whatever you want to design, whatever prototype you want to create, you can work on that. So if I take up a very basic example of lighting an LED, let us take a breadboard. Now this is again, explaining connections to children can become very easier because you have this tool right in front of you. You don't have to make them just draw it on the blackboard and explain it that way. Also, since it is interactive, engaging, children tend to gain more interest, and it is totally game based. So
Okay.
they are playing in a way. And now I've just dragged it. I know I need, see, these are the wires that are coming up. In case you get these wires, you have to click and drop it then and there. And if you click on backspace, they are gone. So these are the handles that we are working with. Now, since I'll be lighting an LED, I need a 9-volt battery. So I take a 9-volt battery. I can see I have got this reminder from the software that what I have taken. I have taken a 9-volt battery. I again drop it. I select it and rotate it. Yes. Then I require an LED. So here I have taken this LED. It is showing near 1 because it is named as 1, and color. You can take green, yellow, orange, blue, red, white, any color LED, and a resistor. So I connect the resistor. Now the concept of anode and cathode also, so it is helping you in that sense. We connect the anode with the positive terminal of the battery. And the other end to the negative terminal. This way children can try out all the combinations and they can figure out whether things are working for them or not.
Okay.
It's a lot of try and error, specifically for the beginners who are exploring the world of electronics. So you can see the LED has started glowing.
Yeah.
And the sense of ownership that children get while they are doing something on their own and the experiments succeed, that is also something really, it acts as a motivation for them. Then also I guess I skipped that, but they need to click on start simulation so that they can see whether the circuit is working or not.
Okay.
Now I can also make a wrong connection. So in a way, when the teacher has to sometimes prove in a class, she can also do some false connection and ask the students why it didn't work. So that provides them with an opportunity to reflect, to think, rather than simply just drawing a circuit diagram in class and asking them to memorize it. Because this lands up like in till senior classes also, they are not able to figure out what exactly they have done. Okay, now few more features, like this wire is green in color.
Right.
So we can change its color also. And if you are stuck with wires again and again, you can always double click on it so that it stops then and there. And release it. Also, you can stop it and delete it. Okay, then we have yes. I can even change the size of color of this LED. Alright.
Could you show us how you can change the color of the LED?
Yeah. So you need to, okay, here I have stopped it, but you need to stop simulation. Then the moment you click on LED, you will get a range of colors. So red. So tell me, which color do you want me to select?
Blue maybe?
Okay, blue. Then again you have to start simulation and you'll see it is lighting up at blue.
Okay.
Stop simulation. Now if you want me to change the color of the wire, so you first select the wire. Here you can see a tool which shows different colors. Which color do you want for the wire?
Yellow?
Okay, yellow.
Yellow is not really visible. Can
Okay.
you make it red?
Alright, so I will make it red.
Yeah.
Here, do you want me to change this as well?
This is okay. So
Yeah.
we got the idea how can the color be changed.
Right. And if we see the wire type, so it's a normal wire. You have to select it first and then
Could you also show us the example of cross connection?
yes. So as I was discussing about cross connection, here you have to make clear distinguish between what happened. Like I showed you when I connected certain terminals,
Yeah.
the LED glue.
Yeah.
Right. Now you need to make cross connections. So obviously a child would not make wrong connections intentionally.
Right.
So it's just like that first wrong connections are done and then he would work on making it correct. So if I exchange the terminals, one second. Yeah. Yes, so if I exchange the terminals, I connect, first of all you can just pick up the wire and remove it from the existing terminal. And I'll connect this one to the positive. Alright, just a second. Also, we can take up a new circuit.
Okay.
New circuit in the sense is wherein we take a new workplace. So that what we are doing exactly is, this is one circuit wherein your action worked, the LED glue. Now when I again click on new and circuit, now I'll be making a false design wherein the LED will not glow because of wrong connections.
Okay.
So this is one small breadboard that I took. We can take other breadboards as well. And here you can see it's a search option. Irrespective of whatever component you want, you can search it. So I clicked on breadboard. Here's a small and here you can see other components. We also have a mini breadboard. So I clicked on the bigger one. Again, we saw the breadboard and its name. Now, coming back to other electronic components, I have this LED. Okay. And the resistor. Okay, another thing I would like to mention here, we can see ohms of the resistor can also be changed.
Yeah.
So based on whatever you require, you can use that. And we need to take a battery. So here I take this 9-volt battery.
Is there any other option in the battery except 9 volt?
Yes, but for school students, we are using 9-volt battery.
Okay.
Here you can, the moment you select it, you'll get, that's more ideal. 9-volt battery is more ideal to use, so that is why we are using it. Now, okay, you said we are going to do and opposite connection. So I'll be connecting anode. See, now I have done the reverse connection and I can see that LED is not glowing.
Yeah.
If you want to eliminate any of the tool from here, any of the component, you simply have to select it like I took this. I don't want battery. By mistake I have taken. So I clicked on it, selected it and backspace. Wires, you can see again and again this green something is troubling.
Yeah.
Right. So that is the wire that is coming. You need to stop it then and there and again delete it. So it will go.
All right. Would you like to show us another experiment, ma'am?
Yes. Also, I would like to take you to some of the existing experiments that are already there.
Okay.
Now, right from the primary classes, we have shapes and 2D and 3D shapes. So this is also, we can see some 3D shapes. Again, start tinkering and you get the workspace for 3D shapes. Then you click on New 3D Design. So this is your work plane. You can take any basic shape or any 3D shape and create your own 3D design. Also, 3D printing, when you connect it with Cura software, you can also take a 3D print of this object.
Okay.
So whatever you are planning in your mind, whatever you are making, you can have it right in front of you in the 3D form using a 3D printer.
Okay.
So before I wind up, I would like to take our viewers to this run through, like 3D printed pop. Then we have some of the toys also made using Tinkercad. So in this manner, teachers can make their own toys. Whatever they are planning to bring into class, they can make it on their own. So they just need to have an idea. Children just need to have an idea and they can design their own prototypes of whatever they want, whatever idea they have in their mind. They simply need to bring that idea into paper and then they can create their own design using Tinkercad.
Okay. All right. So this was pretty interesting, ma'am. And the experiment you showed actually, so that was a science experiment. What if a teacher wants to do another subject specific experiment? Would she or he be able to do that?
Right. So basically the example, since we had only a limited time for the session, I only took one example from electronics. However, as I said, this is primarily a 3D designing software. So whatever a teacher is planning, whatever a social science teacher is planning or any other subject teacher is planning, and whatever classroom tools they require, whatever learning materials they require, they all can be designed using this. Like I showed you the workspace for 3D projects.
Right.
Right. So in that, whatever you're planning, whatever tool you require for your teaching learning process, you can design it on your own once you are thorough with the interface. Okay. At the same time, it offers lesson plans also. So you can see as a resource, there are a lot of lesson plans that the teachers can take help from and integrate project-based learning into their teaching learning.
Okay. Ma'am, when a student logs in, so is there any option where the software asks for the student's age, and is there any minimum age of children?
Okay, so yes, basically if a child is less than 12 years of age,
Okay.
then the child requires authentication from the parent or teacher.
Okay.
So in that case, for young children, what a teacher can do is they can create their classroom and they can share the code with the students so that they can log in. Or a parent can help the child to log in using the parent's email ID.
Okay.
Otherwise, if the child is above 13 years of age and the child has his own Google ID, Gmail ID, he or she can log into Tinkercad.
Okay. All right. So, ma'am, the battery experiment you just showed us, can you show us once again, and we would like to see whether it was saved, or because you didn't show us any saving options. So, is it auto saved?
So now I move to new design again.
Yeah.
And I clicked on to circuit.
The design you created, did you save it?
I did not save it. So what I'll see is, here I can create a new design, and if I go back, into Tinker, circuits, and again start tinkering, you can see your designs. So I just showed you the 3D workplace.
Yeah.
That is also there 5 minutes ago. And the circuits that we did 6 minutes ago, few seconds ago, and 9 minutes ago. So all these circuits we did, even if you are opening the interface and just seeing it, it is auto saved.
Okay.
So here, like the last one, a few seconds ago, I just opened the interface, I didn't do anything on it.
Okay.
So I could see it is coming in my collection.
Yeah.
So it's a record like that, I opened it. And here, this is the one which we did.
Right.
Which we stimulated and we saw the LED was glowing.
Okay.
So again, you'll get it by your name, designed by. In that way, students can have their own collection of designs. So this is not only happening in the circuits part, even in your 3D design. If you click here and you start Tinker, you have a collection of all your designs. So a student can create his or her own portfolio, and 3D designing is not only related to science or maths. Even a maths teacher can well utilize the software explaining 3D shapes to the students.
Okay.
So right from the basic to advanced, graphs, everything can be included in the teaching learning process.
Okay. And ma'am, how many collections can be saved in one account?
So that's a long way to go. There is no limited number of collections.
Okay.
I would advise our students and teachers to just start tinkering, and whatever ideas they have in their mind, it's the right time to bring them into action.
Absolutely. I think the children and the teachers as well, they're going to try Tinkercad as soon as they can, and it's a nice software. And ma'am, this seems like a free version, right? You didn't pay anything for that, but is there any paid version along with it?
Right, so Tinkercad is completely free version.
Okay.
There are other softwares also which are available free of cost.
Okay.
For Tinkercad, you don't have to pay anything. It's a Autodesk Tinkercad, free version available. Then the one disadvantage I would say is that it works well on laptop or desktop. Therefore, I mention it as a mandatory need that you need to have a laptop or desktop in order to work on Tinkercad.
Okay. It can't be used on mobile phone.
No. For Android, we have similar kind of apps.
Okay.
But the effectiveness that you require, specifically if you could see the tools that it offers,
Yeah.
all of them work well on laptop or desktop.
Okay. So on laptop or desktop, we have used right now using internet. But can we use it offline as well, as in without internet?
So for this, internet connection is mandatory.
Okay.
You need to have an internet connection in order to use Tinkercad.
Okay. And would you like to compare Tinkercad with other ICT tools, and how is this particular one better than the other similar ICT tools?
So first, as we have been discussing, it is cost effective. You don't have to pay for it.
Yeah.
Then Apart from this, it is self-explanatory.
Okay.
So a child learns at his own pace, and a lot of things you will find here. You have tutorial for everything. So the child can learn, a teacher can learn, any new person can learn using those tutorials. And wherever you get stuck, you have help with you. Also, again, sometimes you don't have much of ideas, or you want an idea to begin with.
Okay.
So all that is provided by Tinkercad. You can get initially hands-on, you can get through Tinkercad, and then you can create your own designs.
Okay. And would you like to tell us what is the right age group of target audience for this particular app?
So as you saw, there is no right age group. It just depends at what right age you start creativity. Tinkering. So at what right age you start to tinker. So basically there is no right age. Right from kindergarten, as we saw, there were a lot of lesson plans for kindergarten to 2. So there are batches. If we explore the interface, we'll find there are batches right from grade 2, grade Tinkercad till university level students. So it moves from simple to complex. At any level you can start. And also a university level student can come down to the school level and start with basic projects that are meant for grade 6, grade 7. And apart from it, sometimes when we are grown up, children want to get back to their school education, and so this is a platform wherein you get to learn your school concepts but in a newly manner. So that way also I found this application, this software very useful.
Okay. So this was all about Tinkercad. Thank you so much, ma'am, for being with us and for letting us know that this software, Tinkercad, is extremely beneficial for the children, for the students. So this was the details you showed, and even the battery example, that was very interesting, I would say.
Thank
and
you.
I think the children would like to try at their own end what all they can design on 3D or on circuits or on coding. So try it yourself, and if you have missed this program, then you can watch it again on NCRT Official, that is our YouTube channel. Thank you, ma'am, once again for sharing this platform with us. Thank you.
Thank you.
Thank you to all the viewers for being with us. This was a very nice session, and I loved it. I really hope that you too have loved it. So watch it anytime you can on our YouTube channel. And right now we're wrapping up this particular program, and we learned everything about Tinkercad for teaching and learning. Coming up next is another special program of ours, which is Sahayog, and the topic of discussion would be strengthening study habits. Stay here, keep on watching eVidya channels. Thank you once again. Namaskar.